Hello statistics student, this video is for chapter 12, 12.2 and 12.4. We are looking into chapter 12, which is a study of linear regression and correlation. What is it about is if we were given match pair data, X, Y, so that each one of them, so this is a value, right? But it pairs up with another one, okay? The reason why it pairs up is maybe you're getting this data from the same person. So actually, there is an ID here that's that this value and also this value is from the same person, A, B, C, D, right? So you have seen match pair data before in chapter 10 when we do match pair differences. When we do match pair differences, these are same kind of data. If this is score, this is also score. If this is before blood pressure, this is after. But here we are looking at totally different things. So X could be blood pressure, but Y could be the amount of medication that you take or the amount of exercise that you do, right? So they are match pair collected from the same person, but they're different types of measurement. And we want to study if there's correlations between them. So we also want to study if the correlation is linear, and the goal is to use the linear correlation results to predict Y value given an X value. So when we study correlation, the order doesn't matter, but when we do prediction, we want to make sure that we predict Y using X. So when we do prediction, X and Y is important. The two examples that I have here are collected from 5 adults here, collect their height and shoe size, maybe male. Okay, so in general, we know that the taller you are, you have a larger frame. You are, so it makes sense that you have bigger shoe. You would be wearing bigger shoes. So maybe common sense tells us that there are some kind of correlation, but are there? Okay, so we can look at the data. It's not a lot of data, but we'll use it as an exercise. The other one that we collect is children's shoe size and also their test score. So common sense tells us that there should be no correlations, right? So whatever shoes that you wear, the size, that should not affect your score. But are there? We can look at the data because when we look at data like the low number shoe size, they correspond to actually lower test score. This really high number as well as this 10 and 11, it seems to be higher. Are there correlations? So the idea I want to tell you is a lot of time we have some kind of common sense as to whether data are correlated, but when you are presented with data, you don't have to use your common sense. You just look at data value to see if one influences the other. Okay, so the approach to study correlation is twofold. Well, it is not A or B. So we would use graphical as well as mathematical. So they are not like mutually exclusive. You actually use both. Okay. But before we study correlation, one thing I want to emphasize is correlation does not imply causation. Even if we say blood pressure is related to the amount of exercise that you do every day, it makes sense that they might affect your blood pressure. Then the more exercise you do, the better blood pressure or the lower blood pressure that you have. But it is just a correlation. We cannot say causation until we have an experiment, a controlled experiment, or there is, scientific evidence that they are related. So if someone do an observational study or just analyze data by just crunching number, that is just a correlation study. Okay, so remember, correlation does not imply causation. So how to study correlation? So we would do two things. The first is graph a scatter plot. So sometimes we say graph tells a lot of more than 1,000 words, right? So actually graph can actually get a preliminary correlation idea for us. Without doing calculation, we can actually tell if the two types of data X and Y are correlated. So the way you do it is if you have like a match pair data, they are match pair because each pairs are related. So each would be, so this is x1, y1, x2, y2. So we'll just form this as one point. Okay, we are not graphing x and y separately. We graph x, y itself together as one point on a graph. So remember, so sometimes people think that, oh, you're graphing scatter plot. So you just graph all the x, right? All the x graph here, and then graph all the y's here, and then see if they go together. No, this is not scatter plot. Okay, scatter plot is when you get x and y together as one point. Of course, by convenience, we say the horizontal axis is x, the vertical axis is y. So go across and up. So that would be x1, y1 like that. So it turns out that if the points are, after the points are graphed, we call this a scatter plot. Also, you do not join them as a line. Okay, even if you see some systematic pattern, a scatter plot only shows points. If a systematic pattern exists, then we conclude there is correlation between x and y. And this systematic pattern can be linear or nonlinear. So you could have a parabola shape, you can have exponential shape like below. So here, so if I have a graph, all the point, the match pair data and the points are like this, we say there's no correlation. They just randomly shows up. Here, the points are kind of follow a like general pattern, but the pattern is really dispersed. So we call that this weak positive correlation. Positive in such a way that there's some kind of positive slope that you can see. This is also positive because you have a positive slope going up. Actually positive, although it related to slope, it actually just means when x increase, y increase. Both of them increase at the same time and both of them decrease at the same time. And we call this strong positive correlation because the points are very lined up as a line. And this is perfect positive. You can actually see that they actually lie on a line. In the negative side, so if your points lines up like this, so that x and y go different direction. When x increase, y decrease. So you can see this point has a very low x, a very high y. But when x increase, your y drops. So we call it negative correlation. And this is kind of strong because the points lined up. Okay, this is weaker, negative. And these two are called nonlinear correlation. You do not see any general up or down pattern. You see a parabola pattern where the x and y goes up to a point and then goes down. And this is exponential increase. Okay, so in this section or in this chapter, we will only study linear correlation. So how do I construct a scatter plot? Like what I said before, you can manually graph them by putting all the pairs of x and y as a point. So to do it on StatDis, so of course we use StatDis to do. You can actually do this in Google Sheets. Excel can also have very easy way of graphing scatter plot, but for the analysis of data, consistent with analysis of data in this class, we would use StatDis. So this is StatDis. What you do is, so I have enter height, shoe size data as a pair, right? This is a pair, 5 adults, and also have 6 children's shoe size and math scores here. So let's graph this to see what it looks like. So graph, because when we look at the number, we can just look at one at a time, but when you see a picture, it's easier. So to do it, you see data. Under data, there's a scatter plot. So you would say, what do you want? I want the height and shoe size because they are matched pairs. You can also draw the title. You say scatter plot for height and shoe size. And then you have the X and Y label, which is the column label. And because we're doing scatter plot, we don't want line, so we would uncheck this, uncheck show regression line. We'll talk about regression in the next video. So these are the scatter plot. So x-axis. Usually when we copy this down to our assignment, we would copy the y and x-axis, and please actually copy the scale and the title. So you know that this is the x-axis is the height, the y-axis is shoe size is from 8 to 12. You don't have to start from 0, 0 because our goal is to see the pattern, not the relative differences or anything. So because only have 5 data, there seems to be some kind of upward pattern, but because the numbers are so low, it's hard to tell if there is a very strong or weak pattern. So if I am to copy this down, I'll copy it as, so do I have place I can copy it down? No. So just remember if you are to copy it down, that's how you do. So the other graph that we are, the other method that we do is mathematical. So instead of graphing a scatter plot, we would calculate a number. So this number is useful. It can help us to determine if linear correlation exists, but in conjunction with scatter plot. So you cannot just do one, you have to do both. By looking at scatter plot, sometimes it's hard to tell, right? So sometimes it's hard to tell, is it weak or is it no correlation? Or is it strong? Like at what degree is it strong? So this correlation coefficient R help us to do that. It helps to tell us if it's a positive correlation and negative correlation. It can also see the strength of the linear correlation. A very strong correlation will show up in R. So how do you calculate it? So how do you calculate a linear correlation coefficient R? So this is the formula to calculate it. And a statist certainly can do that, right? So to do it, we would use statist analysis, correlation, regression. So these actually are the things that we generally do. So you would have the data inputted, and you do analysis, correlation, and regression. So we don't care about the significance yet, but we will do height for X and shoe size for Y and evaluate. So the number that I want you to pay attention to is correlation coefficient R, 0.8485, and critical R. So that's two number, 8485. The one that describes this set of data is correlation coefficient R. It tells you how related they are. The critical R is a threshold. Okay, it's plus or minus 0.8783. And there is a p-value. We'll talk about those later. Okay, when we are in this in the section where we talk about how to determine if the correlation is really linear. Now, correlation coefficient R is a number that reflects two things: the strength and also the direction of the correlation. In this case, R is positive. That points to the fact that, okay, see, there is a scatter plot here actually. This scatter plot is not as good as the one that we have because it has the line and there is no way you can off it. So if you are to graph a scatter plot, use the data scatter plot one. If you are to do just look at how does the graph look like, you can use that one. So positive, you can see that the line is positive, right? It has an upward trend. Also, it is close to 1. 0.8 is closer to 1 than closer to 0. So we say it is a strong correlation. Okay, so let's look at the material again. So some properties of R is between 1 and -1. If you do a lot of this match pair data, you would not see it over 1 and -1 because when it is 0, it's no correlation. When it is 1, that means perfect correlation. So we'll continue in the next video.